Hello everyone, welcome to Term 3 Curriculum Structure Presentation. My name is Shog, and in this video, I will explain the first part of the curriculum. We will explore the main lessons, review the key ideas, and solve questions together. Let's get started with Lesson 1. Now, let's start with Lesson 1, Translation on the Coordinate Plane. First of all, a translation means moving a figure from one place to another without changing its shape, size, or direction. So there are four basic rules. So right means add to the x coordinate, and left means subtract from the x coordinate, and up means add to the y coordinate, and down means subtract from y coordinate. So now let's look at the example. So point A is at 2 and 3. We will move it 4 units to the right and 1 unit up. So step 1, we need to add 4 to the x coordinate. So 2 plus 4 is 6. And step 2, we need to add 1 to the y coordinate. So 3 plus 1 is 4. And then we will have the new coordinate. It is 6 and 4. So this is how we perform a translation on the coordinate plane. Now let's solve this example together. So we need to translate triangle ABC 4 units to the right and 1 unit up. So whenever we translate a figure 4 units right and 1 unit up, we use the rule x. So the rule for this question is x plus 4 and y plus 1. So this is the rule of this question. So this means we add 4 to every x coordinate and add 1 to every y coordinate. So let's start with point A. So this is point A. So the point of A is -3 and -3 and -1. Oh, -1. So after the translation, it will be A dash will be -3 plus 4 is 1, and 1 plus -1 plus 1 is 0. So this is the point. So and then we will go to point B. So point B is at -4 and -4. -4 and -4. So we will add for B dash, we will add 4 plus -4, it would be 0, and 1 for -4 plus 1 is -3. And then we will go to point C. So C, the point of C is at -1 and -2. -1 and -2. So C dash will be 3 and -1. So the coordinates of the image is A dash is 1 and 0, and B dash is 0 and -3, and C dash is 3 and -1. So this is the answer of this question. Now let's move on to lesson 2, reflect using coordinates. A reflection is a transformation that creates a mirror image of figure across a line. So the two most common lines of reflection are x-axis and y-axis. When we reflect a point across x-axis, the x-coordinate stays the same, but y-coordinates change its sign. For example, if a point is at 3 and 2, after reflecting across the x-axis, it becomes 3 and -2. When we reflect a point across y-axis, the y-coordinate stays the same, while x-coordinate change its sign. So in this lesson, you need to remember that across the x-axis, you need to change the sign of y-axis, and across the y-axis, change the sign of x-axis. So now, lesson 3, reflection on the coordinate plane. So think of a reflection as a mirror image. The shape and the size stays exactly the same, but the figure just flips over a line. It is really simple if you remember these two main rules, that when we reflect across the x-axis, the x stays the same while the y changes. And reflecting across y-axis, the y stays the same and the x changes. So what if the reflection is across other lines? Just remember that a point and its image must be the exact same distance from that line. Okay, so let's solve this question together. So first we need to identify the point. So we have point A is -2 and 3, and B is at 1 and 3, and point C is at 1 and 1. So we will use the counting method. We are reflecting across the x-axis, so we need to draw a line right on the x-axis like this. And then we will count the distance. Look at point C. So it is exactly one square above the line. To reflect it, we just go one square below the line. So it would be like this here. And then repeat for others. So point A and B are 3 squares above the line, so we will count 3 squares down and mark them at under the line. So 1, 2, 3. Here's 3. Oh, here's 3, and then 1, 2, 3 in here. So connect your new points A dash and B dash and C dash. So it would be like this, like this, like this. And then we will write it. A dash will be -2 and -3. B dash will be 1 and -3. And C dash will be at 1 and -1. So these are the points after we reflect it. So that's it. Now we're gonna start with lesson 4, rotation on the coordinate plane. So you need think of a rotation as a spin around the center point, which is 0 and 0, the origin. The size never change, just the position. So for 90 degree, just swap the numbers x and y and change the sign of the new first number for clockwise, counterclockwise, or the second for the clockwise. And for 180, for 180 rotation, it is the easiest one. You just keep the numbers in the same place, but you flip both signs. So x and y becomes negative x and negative y. You don't swap anything here. Just change both signs. And for 270 rotation, don't worry about memorizing a new rule. Just remember it is the same as a 90-degree turn in the opposite direction. So 270 counterclockwise is the same as 90-degree clockwise. So you swap the numbers and change the sign of the new second number. And 270 clockwise is the same as 90 counterclockwise. So you swap the numbers and change the sign of the new first number, negative y and x. Just remember 180 is flip both signs, and 270 swap and change one sign. That's the secret. So let's go and solve a question. Now let's rotate polygon EFGH 90 degree clockwise around vertex H. Remember the rule. For a 90 clockwise rotation about the origin, the rule is x and y will be y and negative x. So we flip it and change the sign of the second number. So it will be y negative x. Okay, so we will apply it now to the points. So first of all, we will write the points. So E is negative 1 and 3. So it will become, we will flip it and change the sign of the second number. So it will be 3 and 1. So the second number is 1 and 4. It will be 4 and negative 1. And J and G, it will be 3 and 3 will be G dash 3 and negative 3. And the last one will be the H. So the H is 0 and 0. So we will not change it because it is the center of the rotation. So H dash will be 0 and 0. So just plot them and you will connect them, and you will see the whole shape has turned perfectly to the right. Always remember, when you rotate around a point, that point itself never moves. So let's go to the next lesson. Lesson 5, applying rotation rules. We've learned the rules, so now we're going to use them to solve problems. It is super simple. If you need to find the new coordinate, just pick the rule for the rotation like 90 or 180 and apply it to your point. For example, if you have 2 and -3 and need a 90 clockwise rotation, just follow the rule y and -x to get -3 and -2. And if you need to identify the rotation, look at how the coordinates change. If the numbers swap, it is 90-degree or 270-degree turn. Or if the signs just flip but the numbers didn't change or didn't flip, so it is 180 turn. So always check your result on the graph. A rotation should look like a smooth turn around the origin. If your shape looks flipped or mirrored, you might have used a reflection by a mistake. So keep practicing. So these are the rules. So 90 counterclockwise will be negative y and x, and clockwise will be y and negative x. 180 will not change either direction, like counterclockwise or clockwise. So it will be negative x and negative y. And for 270 clockwise, it will be same as 90 counterclockwise, so it will be y and negative x. And for 270 counterclockwise will be same as it will be same as 90 clockwise, and 270 will be same as 90 counterclockwise. So point Q is at -3 and 2, is rotated about the origin and maps to Q dash 2 and 3. So it has flipped the numbers and changed the sign of the second number, which rotation was performed. So when we change x and y and go into y and negative x, it will be 90 clockwise rotation. So now we're covering lesson 6, dilation on the coordinate plane. Think of a dilation as zooming in or out on a picture. It changes the size, but the shape does not change. It stays exactly the same. So the most important part is the scale factor. So if the scale factor is larger than larger than 1, it is enlargement, so the figure will get larger. And if it is smaller than 1, the figure gets smaller, which is reduction. So the rule is super easy. Just multiply both the x and y coordinates by the scale factor. And if you need to dilate the point, for example 2 and 3 with a scale factor of 3, just multiply both numbers. So 2 multiplied 3 is 6 and 3 multiplied 3 is 9. So it will be 6 and 9. It is just multiplication. As long you know your scale factor, you can find the new coordinates in seconds. So Keisha used a photo that measured 4 inches by 6 inches. So we have 4 inches and 6 inches. To make a copy that measured 8 inches by 12 inches. So 8 by 12. So 4 got to 8 and 6 go to 12. So it is multiplied by 2. So the scale factor is 2. So is the image an enlargement or reduction? So it gets bigger, so and the number is bigger than 1, so it is enlargement. And that's it. So lesson 7, composition of transformation. So a composition just means we are doing 2 or more transformation in a specific sequence. So these are the transformation we use: translation, reflection, rotation, and dilation. This lesson just like it is the whole unit in one lesson. So let's solve this test practice question together. We need to find the transformation that maps trapezoid and its image. So I think it is a reflection because like it is across x-axis, like it is the same distance from R to the line and M to the line and S to the line and N to the line. So I think it is a reflection. So let's check if we have a reflection in the choices. So this is dilation. I don't think it is dilation because it does not get bigger or smaller. It is the same size. So this is not dilation. Translation. It can be no, it cannot be translation because like it is flipped around, so it cannot be translation. So reflection across the horizontal line. So yes, this is the answer. Reflection across the horizontal line. And rotation about vertex. This is not a rotation. So the answer is C. So this is the easiest lesson, which is congruent figures, identifying parts and missing measures. So let's go into the questions. Okay, so we will write, first of all, we will start with corresponding sides. So M and R, from here to here, it is the same as P and L. So the answer is P, L. And then we will go to R and K. R and K. It is the same as P and Q. So P and Q. And M and K. So it is the same as no. Yes. It is the same as L and Q. L and Q. So let's go to corresponding angles. So we need to find an angle same as M. So it has 2 lines. So this one, L. So you go to L. And then R, this one, so P. And then K, it is Q. So Q. So this is how you solve it. So this is another question. So we need to write the corresponding angles and corresponding sides. So first of all, we will start with corresponding angles. And here we'll write corresponding sides. So corresponding angles, we will write, so first we will choose 2 points, so U and S. So we got S and U. It is the same as t and y. And S and W is the same as T and X. And W and U is the same as Y and X. No, X and Y. These are the corresponding angles. So now let's go to corresponding sides. So S is the same as T. So angle S sorry just a second. This is corresponding sides. This is corresponding angles. So S is the same as T. X is the same as U is the same as Y, and W is the same as X. So this is how we solved this question. That brings us to the end of part 1 of grade 8 Advanced Mathematics Term 3 curriculum structure. In this part, we explored the first 8 lessons and practiced some important skills together. I hope this explanation helped you understand the main concepts. And to continue with the next lessons, please watch part 2. Thank you for watching.